Mass spectrometry. What is mass spectrometry? Mass spectrometry, MS, is used to determine the identity of molecules within a mixture by mass-to-charge ratio of ions, M/C. The mixtures are separated out based on their size, producing a mass spectrum. MS is used to determine the changes in molecular composition, surface properties such as adhesion and reactivity, and their interactions. There are multiple types of mass spectrometers, but they usually work in a general way. The mass spectrometer is in constant vacuum to remove any air particles. Once the sample is inserted, it is hit with a beam of electrons in the ion source, breaking the sample into ions. The ions are then accelerated through the mass analyzer by a calibrated electrical field and magnetic field. The electric and magnetic fields have been calibrated to deflect the unwanted ions, such ions that are too heavy that bend too little, and ions that are too light that bend too much. The wanted ions then hit the detector, producing a mass spectrum.
Next, we'll talk about mass spec figures of merit. Resolution is the capability to differentiate between masses. This quality depends on application. For example, differentiation between two ions with the same mass numbers requires higher resolution. Instrument detection limits are defined as the concentration of analytes required to produce a signal distinguishable from the noise level, the noise being the fluctuation in the instrument background signal. The detection limits are very low for mass spec, approximately in the femtomolar region, which is 10 to the minus 15th molar. Selectivity is the extent to which a method can determine particular analytes and mixtures or matrices without interference from other components. Combining liquid chromatography and tandem mass spec can produce selectivity that is required for legal action, so this technique is reliable enough to use as evidence in a court of law. Here we have a mass spectrum of polyglycol, also known as polyglycolic acid or PGA. On the x-axis we have the mass-to-charge ratio, M/C, and on the y-axis we have the relative intensity. The highest peak of the spectrum, called the base peak, is automatically set to 100, and other peaks are assigned values based on their peak heights relative to the base peak. The base peak indicates the number of carbons. Because the base peak is at 31 mass to charge, there will be 2 carbons based on the atomic mass of carbon. In the polyglycol structure, there are 2 carbons. If you analyze any mass spectrum, you will find that the mass to charge ratio of all added peaks equals the molecular weight of your test sample.
The advantages and disadvantages of mass spectrometry. The advantage: it is simple to use and easy to interpret the data, only requires a fraction of the sample, you obtain fast results, and it's fairly inexpensive depending on the type of mass spectrometer. Disadvantages: must be calibrated correctly, it will only analyze the surface properties of your sample, decay rate of the sample, so that's saying that if the decay of the sample is at high, then by the time it hits the detector, you're not going to read your sample. Contaminants as a part of the side reactions or the sample itself. Side reactions as in the sample is forming side intermediates, or the sample is contaminated in the lab. Mass spectrometers can be found here at UNM on North Campus and in the chemistry department. The chemistry department has the MALDI, MS, and the GPC.
Software can be used to analyze your peaks as well as the spectral database for organic compounds, where you can search for mass spectra of your polymer assigned in class, and you can also learn more about fragmentation patterns in mass spectra from the ChemWiki by UC Davis. Here are our references, and thank you for your time.